Hello everybody, this is That Programming Guy, and remember, you guys can do the thing. How are you all doing today? Today is, I need to text my sister. Today is Saturday. Saturday the 12th, not the 12th, fucking A, it's the 10th, the 2nd. I have had too much coffee. I don't know how it is for you when you guys have too much coffee, but sometimes when I have too much coffee, my body will actually shut down until some of it gets out of my system. So I'm now just kind of finally getting that coffee out of my system, so I'm starting to slowly wake more up and actually be ready for programming. Probably I would start in like 30 minutes if I had a choice, but I don't have a choice. And also, nightbot.tv. Log in, please. Let's change some shit, shall we? We are going to... What the fuck? What the hell? Control V, yes. Edit. Submit. There you go. Nightbot, you can do this. I believe in you. Alright, so that's going to be minimized. Alright, so how are you all guys doing today? I hope you're going well. Remember guys, you can do whatever you put your mind to. I believe you guys can get it done. So, this is Haskell. More Haskell, guys. So much Haskell. Oh my god. I've been doing this so long. Thank you for staying with me. Active Fireball did manage to get donations for No Shave November, so I will not be shaving for the whole entire month of November. I'm excited. Anyway, so where are we in this adventure of Haskell? So, what we did last episode was we took basically kind of all of this and we changed it to make it work how we needed to. Basically I had, apply direction, I had the pattern match twice, and the where only worked with one of them. So I put this into a guard statement, right? And so, however, once this started compiling, direction had to be an IO of a direction, which then changed everything else, which means I'd had to put this into a do syntax and use the monad notation, all of that other good shit. So, what we're going to be working on this episode... Oh my god, I'm so tired. What we are going to be working on this... I should turn the light on too. Jesus Christ. There you go. Now you guys can actually see me, huh? Alright. Oh god, did you hear that? That was my knee popping. I wonder my left knee pops, not my right. It's so annoying. Anyway, what we'll be working on is basically moving the random call to as far late as possible. So what I used to do was go, if you're north, do north. If you're east, do east. If you are anything else, here I would actually call get a random direction. No, sorry. This would take in an IO of direction, which means what called here, whatever called apply direction, would have to deal with IO and all that other wonderful good shit. But I don't want to deal with that. So how we're getting around that is we're basically cell with direction. Directions. Get direction is actually going to return. Get rid of them. North, east, or random. So if we go to here, go to move. If we go to get random direction, get random sorry. What am I looking for again? Get direction, not get random direction. Do I have a get direction in here? I don't know if I do. Get direction, yes. This will basically take its index, and this is going to return a direction, and it'll go, okay, basically either return east, north, or random. We can actually get rid of these pures. Since we don't need to put them into a thingamabobber, so we're gonna... Hi, Lucy, I know, you exist. Do you want to get out of the room, or do you want to stay with me? What do you want to do? Do you want to leave? Puppy, do you want to leave and see Tyranny? Go on. Do you want to leave? Alright, so now we have no more puppy in here. Alright. Okay, so that's what we're gonna do. We're basically gonna make get direction return a random. And we're going to basically take get random direction. We're going to call this as late as humanly possible. That's the idea. Oh boy. Like, I wouldn't mind doing these more on other days as well. Sometimes I wouldn't mind doing this in the late afternoon, but I just have no time. Well, I do have time. I just want to get this over with. Like, I enjoy doing this, guys. I just want to let you know, guys and gals, I do enjoy doing this. It just sometimes I wish I could sleep, you know, I sleep till 9 and not do any of this on the weekend. It would be nice if I could not do this on the weekend. I could have the weekend streaming free. But it's for another time. Okay, so that is what we're going to do. So I guess the first thing is I want to do this. Let's get rid of IO direction. This is going to go away. These are going to do that. Cool. So direction, we'll get direction. Now we have directions. Icon, I'm going to put what this is here. Cells with the directions, we're going to mix those. And we're going to apply direction. So, we're going to go if north, do that. If east, do this. And I'll have to add the bidirectional neighbors here. I hate how you fucking do that. That's so annoying. Then random will be interesting. And I will need these to apply the bidirectional neighborness. I actually technically could not apply the bidirectional neighbor and just go through the maze and then have neighbor cell and neighbor index be a different method. We're going to leave this right now. This is a pretty chunky method right now. If the direction is random, then we are going to want to then get a random direction. This means this is going to return an IO of a maze, and it's going to get in an IO of a maze. That's actually quite interesting. Another idea that's actually kind of interesting that I could do is I could just basically from index 0 through 25, so basically replicate number of cells, I could just get random directions, and then cells with the directions would be a tuple of cell direction and an IO of a direction. And then maze with the directions would take in this tuple. But then... Interesting. That's another idea. Okay. So let's think about this, shall we? So during this time, what would happen is if I was at work, I'd be like, okay, let's take 5 minutes and go into Reddit or Twitter. Oh boy. Okay, so you can go away. I don't need you anymore. Okay, so we have this. We have this get direction and return a random. And then if random, we need to call or even better. Even better. Here's what we can do. Even better. I think I have a better idea. We don't deal with the random index now. We just deal with this. So that means we can go through it a second time and we can apply the random direction to it. That might be an idea. And so this will be get all the empty cells, get all the directions, zip them together. And then we have the maze with directions. Refold L, apply direction, empty cells, and cells with directions. So we're only dealing with the north and east right now. And then we'll call it again, and then we'll go, okay, if random, do this. We'll try that. That's a good idea, me. I'm smart. I try to be. I have no idea if I'm doing anything correct. Fuck, I'm so tired. Oh my god, I'm so tired. Okay. No laptop. You don't be a dick. You stay. By the way, guys, I don't know if I've said this before, I have no idea if I've said this before, but don't ever get a Razer laptop. Their Chroma keyboard is pretty. It's a sleek keyboard. It's a sleek laptop. It feels nice and everything. It's colorful, but don't fucking get them. I've had this thing crash on me way too many times. I've had it where I turn on the computer and then the keyboard's non-responsive. I've had it where I turned on and the keyboard isn't lit up until I actually log in. I personally don't like the chiclet keys, so that might be a thing that I don't like. In general, I've had a lot of problems with this laptop, and I don't enjoy it. So, Razer laptops, they look good, yes. Get other laptops. No. Anyway. Okay, so Northeast, and then I guess I could also apply the direction, and then I'd have to go through and apply the bi-directional neighbors. That's actually a good idea. Let's do this. Apply direction. We're going to have a apply bi-directional neighbor. This is another, we're going to take a maze. We're going to take a cell and a direction. We're going to return a maze. Actually, yes. We're going to do the same thing. We're basically repeating this. Let's just take this. With that. However, I see. And then I have the neighbor cell and neighbor index. So I'm basically repeating the same thing. I'm just doing the... fuck it. Yeah, we don't need this. We're just going to do this. Oh, now my dog wants in? Okay, guys, hold on. Lucy! You gotta make up your mind, baby girl. Let me push the door open, you little fucker. No, you know the rule. You know the rule. If you disturb my stream, you have to say hi to people. Okay? Say hi, Lucy. Say hello. I know, she's in a cone right now. She's scratching her tail. I gave her some flea meds in October, in the middle of October. Gonna give her some flea meds today, and additionally, he's keep my ear warm. Additionally, I'm going to wash her stuff. Okay, so now we have to do that, which is sell. We're going to do the other thing, which looks like this. GitHub.com/me repos. Maze algorithms updated 7 days ago. No, not C# mazes. I need Haskell mazes. Source. Oh, what is this? I'm in main.h. Oh, I'm in main.hs. Okay, we're gonna go to app. That's what I'm looking for. Do I have that here still? I do. Great, wonderful. So I'm going to do I'm gonna go like that. We're actually gonna do this. There we go. Okay, so then we are going to do maze ix at index. We're going to do ix at neighbor index. We are going to do that. We're going to do that. We are going to do that. We are going to do that. This is going to be a dot tilde instead. And then we are going to end that with a I think that works. We're going to build this and see what happens. Stack build. Will you build? No. Ooh, error. Variable non-scope boolean. T. No, dog, you're not gonna fuck you, dog. You're not getting out of here. I'm sorry, Lucy. Variable non-scope neighbor cell. There we go. And yeah, that's because I spelled them wrong. Oh, variable non-scope neighbor index. Again, bad misspelling. N-E-I-G-H-B-O. Ah, there's no H in here. You need to be like that. N-E-I-G-H-B-O-R. Neighbor index. Neighbor index is going to go right there. I'm assuming this is all N-E-I-G-H-B-O-R. There we go. Another build. Oof. Okay. Now what's going on? Okay, we're gonna clear this. Stack build. Error. Couldn't match BO to BO with cell. Expect to type an A setter. Expect to type that in first argument that, namely of IX index. Okay. Should we get rid of these? And then if this doesn't work, I guess I can just add the bi-directional neighbor in a totally separate thing. Oh my god. There's so many errors now. Okay. This is being stupid. And I don't really know how to fix this. And right now, I don't want to go through how to fix it. So I'm not gonna go through how to fix it. Here's what I'm gonna do instead. What if I do that? I do that. And then if this doesn't work, I'm just gonna separate this. Fuck. I'm just gonna separate this out into 2 different function calls. Because I'm too tired of doing this. I'm so tired. Why am I so tired? My god. Alright. So I'm going to separate these out into two different function calls. So we're going to apply direction, which means we only need the index, and then we're going to apply the bi-direction, which is basically the same thing. We're going to take a maze. We're going to take a cell and direction. Maze, and we're going to call this apply bi-direct. We're basically doing the same damn thing. That's what we're doing. We're doing the same damn thing. Oopsies. Except we don't need, this is going to be that. Right. If north, make a south neighbor. If east, make a west neighbor. And we are not going to need that. And this is, we're not going to need that. Alright, so now, technically, I guess I could parameterize these a bit more. And pass in what I need, but it's good enough right now. There we go. So I'm just going to have to call this twice. So maze with bi-direction. Oh no, I can't add the bi-direction yet. I will add the bi-direction. Let maze I will need to add the bi-direction. However, I also have to deal with the fact that I still have the ones with random in it, which means I'm still gonna have to add those bi-directions. So really, I'll need to apply direction. I will then have to change the random when I get a random to change it. But here's the thing, though. This is really interesting. If I change, so right now we have to apply direction, takes a maze, a tuple, and returns a maze. And before this, the tuple will have random in it as a direction. And if it's random, I don't do anything. The idea here is sorry. The idea here is that once that's applied, I'll need to then change those random directions into, I have to go through it again and go, okay, if it's random, get a random number, and then if it's 1, it's north, if it's 0, it's east, do that thing, and then apply the direction of bi-directional neighbor. And that's going to be one method that I'm hoping for. So if I have these split into two, I have apply direction and apply bi-direction. I could go, okay, cool. Now change the random to a direction, which is great. However, the next thing that I'd have to worry about, though, is that how would I apply the bi-directional neighbor when I'm converting the random to a random direction? Because if I go apply direction, convert, and then I do it again, but I say, okay, instead apply random direction, that's going to turn me an IO of a maze, and it's going to take an IO of a maze. Which is fine, I guess. But, then, okay, so we have, right, we have apply direction. We have apply direction, which basically puts in north or east. Great, we have that. We have apply random direction. Or, we could do this. We could do this. Another way to do this, which is, what I had before was direction would be an IO of a direction. And then that way, I know what to do here in a cake. If I get an IO of a north, do this. If I have an IO of an east, do this. I could do that. That is another option. That is what I was actually jonesing with before. Is there another way to do this, though? It's a very good question. Where is my mouse? Come here, little mouse. Right? So we've applied direction. So if we can get the bi-directional neighbor thing to work, that would be great. If we could go... Interesting. How would we do this? We have apply direction, which basically sets up north and east. Then we can apply bi-direction, which again does north and east. I could do this. Here's an idea. I could go apply direction, apply bi-direction, right? And then what I could do is all the directions, basically go through it, and all the directions that are random finally get an IO, and get an IO of an int, or IO of a direction. I have to combine them with the cells. So I'd get a tuple of cells with an IO of a direction. All those cells are the ones that needed to be random. I could then go through again and do apply direction and apply bi-direction. but instead of being a direction, it would be a tuple of IO of a direction, which means the maze would finally have to be IO. That is one way to do it. So it would be based on have 4 methods, and this would be like really chunky and look horrible. We'd have apply direction, apply bi-direction, we would have get random. Then basically this would be apply IO direction. And then we have apply IO bi-direction. That seems cool. But then that would mean index and neighbor cell and neighbor index, I believe, would then also have to be IO, because that would touch an IO of direction, which would be fugly. So that is one way to do it, but that spreads the IO everywhere in the idea, so try to make it so the IO is not spread everywhere. So I bet there is a non-IO intensive way that I can get this done. So the problem that we're encountering right now is we could make apply direction and apply bi-direction take an IO. So basically it would be a tuple of cell and IO of a direction, which means the maze would have to be an IO of a maze. But convert point to index, get neighbor cell from cell, and get neighbor index from cell would then also have to deal with IO. Because, excuse me, this and this cell and direction would be a tuple with an IO of direction, which means this, since it's messing with IO, would also have to be declared IO. Which so then basically, once we change, well, basically if we pass in an IO of a direction into this, everything is being IO, and that's not what we want. So the question is there a way to avoid putting IO everywhere? And so I think I did a good first step, which was make it so we get random. That's good. So we've applied direction, apply bi-direction. That's what we need. So now, after apply bi-direction is finished, after apply bi-direction is finished, the only cells that have had not directions applied to them are the ones that are random. Now with these, I'm thinking, now with these, right, we then need to take out that random. I think that's what we need to do. I think that's the best way to do it, is take that tuple of cell and direction, go through them. For everything that is random, change it into an IO of a direction. I think that's what we're going to have to do, and then we're going to have apply IO direction, apply IO bi-direction. No, right, because, right, that's the idea, is then everything else would get IO in it. Fuck. This is a really interesting problem. It's almost like the problems that I had when, not the problems when I had, but it reminds me a lot of those other episodes where I just kind of spent talking a lot. Anyway, guys, it is about 30 minutes of some shameless advertising coming at you right now. I sell t-shirts. I sell merchandise. They're pretty fucking awesome. Right now, they're just shirts. I'm only selling shirts, but they're really fucking great shirts. They're premium cotton shirts. They're awesome. And they have a nice unicorn with a rainbow on them that says, "Remember, you can do the thing." These are great shirts, guys. Like, let me just show them to you, you know? So if you go to www.thatprogrammingguy.com, right? Click on this picture right here. Boom, shirts. They're great. They're wonderful. They feel nice. And look, here's an action thought. Jesus Christ. Action shot. I'm still tired. It's a white one. You can get white or black. it looks really good, guys. If you want a shirt that's gonna make you stand out, man. Also, if you're going to an interview, guys, if you're going to an interview and you want to stand out and you want to make sure they remember who you are, this shirt, I guarantee it, they will remember you if you wear this shirt. It's great. It's fantastic. Anyway, these shirts are $40. $40. They're great shirts. It's awesome. Go to www.thatprogrammingguy.com/merc or just click on the picture on the front page. Bring you right here. Both women's, both men's. We have all the way down from extra small, I think, small to 3X large. Oh, God, they're fantastic. They're great. Guys, buy one of these shirts. It supports me. It supports the stream. It supports the YouTube channel that you guys are probably watching this on. Which is great. Additionally, I do offer program coaching. So if you need help with anything programming related, if you need help with things like how do I even get started with programming, what should I learn, where do I go, I have help with my coding school homework. I have help with my college homework. I need help with this. Maybe I'm having this problem, this job that I don't know how to solve. I don't know. Anything and all a thing. Jesus fucking Christ. Programming related, I can help you with $60 an hour. When you book me for the first time, we'll have like a 30-minute chat as well to be like, do I like you? Do you like me? Can we actually work together? And what problems do you need help on? Because one, as a coach, I need to know what you need help with so I can figure that out. But additionally, you know, if you don't like me in the first place, and you're not going to learn anything from me as well, which is the thing. So if you do want some program coaching, if you want to talk to see what it can help you with, which is kind of everything, send me an email at darren.hona@thatprogrammingguy.com. Since that shoots me an email, send me an email. Let's get talking. Program coaching, $6 an hour. It's a fantastic opportunity, fantastic deal. You get coached by me, that programming guy, which is just pretty fucking awesome, you know? Anyway, thank you very much for the shameless advertising. Dog, you're not getting out of here. I'm sorry. You're gonna want to come back in because you're bored. Okay, so back to this problem. So, is there? I mean, technically, what we could do is this. We could make this tuple. I guess we could also have a cell metadata, which is a cell, a direction, its index, and then its neighbor cell and its neighbor index. So I could do that and then pass that around. And then I can make the tuple, and then that's actually, I think that's the way to do it. I think that's a good idea. So we're gonna have a tuple with a cell, a direction, the index, the neighbor cell, and the neighbor index. And then that way, we can calculate the index at the neighbor cell and the neighbor index without getting into any I/O. And so applied direction will take a maze, the cell metadata, return a maze. The applied bi-direction will take a maze, cell metadata, and then the maze. And then from there, when we have to whittle down, we can whittle down, get all the randoms, and then we can apply it, and that will return an I/O maze. I think that's the way to do it. So let's get this going. So I'm going to have another thing here. This is a maze, and we're going to have a... No! Also, guys, I discovered this recently, and I fucking love it. Watch this. Are you guys ready? We're going to do a dir. We're going to cd into source. We're going to do dir. If I do a notepad++, I'm going to just do boom.hs. It opens up all of the HS files in that directory. Oh my god. It's so cool. I'm so excited. Anyway, so how do we declare a cell? Data cell equals cell. Here's the record syntax. We are going to go to comment lib. We don't need lib. We're gonna put this into a maze. And the reason why we're gonna put this into a maze is because a maze has so. So we're gonna call this a cell metadata. and it's going to have a constructor called cell metadata, and it's going to have a cell, which is of type cell. It's going to have an index, which is of type index. It is going to have a neighbor cell, NEIGHBOR cell, which is of type cell. And it's going to have an NEIGHBOR index, which is of type index. Index. And then, cool. All right, cell metadata has a cell, has an index, neighbor cell, and neighbor index. And then that way, this, okay, we're going to comment out all of this right now because I don't want to worry about it, right? Oopsies. Excuse me. Sometimes I get confused between shift and control when I'm using them interchangeably. It's crazy. All right, so we're going to take apply direction. We're going to comment this out as well. Cancel. Okay, okay. So we have a list of empty cells. Number of cells, make fresh cell. This is not what we need. We need a cell metadata. Make fresh maze. Okay, we're gonna do that. Let's have some fun, yo. Let's have some fun on our disco stick. We're gonna have a make fresh cell. We're gonna have a make fresh maze. We are going to call replicate number of cells. Replicate number of cells. Wait a minute. We need to oh, yes. Okay, so this is doing this, right? Number of cells. Going to call cell metadata, which is not a maze at all. It's a list of cell metadatas. But so basically kind of what I want to do is I want to list all the cell metadatas, which is a maze. So I think a cell metadata, God, I need a better word for that as well. And we do it as in, I think I know how I did it here. Yeah, make fresh cell equals cell. We're going to call the function to make this, which is called a cell metadata. Wait, hold on. What do they do? Yeah, equals. Okay. I'll make fresh cell. We're going to need is that possible? How do we get the index? Convert point index row dot cell column dot cell. That's not gonna work. Okay. Okay, so make fresh cell. How do I get the index? How do I get the index? Convert point index, row and column of the cell. Cell.hs, false, 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 0, 0, 0. So if we follow make fresh shell, get direction, zip, apply direction, convert point to index, the row and column. When do I assign? Actually, here's another question that I have. When the fuck do I apply the row? When do I actually specify what the row and column of the cell is? I don't think I actually do that. Make cell, make fresh, number of cells, get direction, is valid point, convert point to index. Convert index to point, is valid index, move. Get random direction, get valid moves from index. So I actually never convert. Okay, this is interesting. Okay, so I just found something else. So this makes a fresh cell. This makes a fresh cell, but I never change the row and column. I should, that needs to change. Huh. I do have get index to point though, which is fine. So I could do that. So I could go is there like a replicate and have the index at the same time? It's not. Cycle, iterate, repeat, and take. Takes a list of returns. It creates a circular list from finite one. Okay. Interesting. Creates an infinite list where the first term is calculated by applying a function to the second argument, the second item by applying the function to the previous one. Oh, interesting. Fancy. Creates an infinite list where all items are the first argument. Creates a list. The first argument determines how many items should be taken from the list past the second argument. Okay, that's not what I need. Okay, so I like replicate. That's cool, yo. Replicate is awesome. Is there one where I can actually keep the index, though? Scan L, scan R, accumulating maps, no infinite lists. Replicate. Replicate n, x is a list of length n with x the value of every element. It's an instance of more generic replicate in which n may be of any integral type. Okay. It's not what I need. So what I need, so basically cell metadata, right, is going to go, okay, if I want to make a number of cells, right, I'm going to have to make a fresh cell to make the cell, but then I need the index and the second cell and the neighbor index. So I mean, I could do this. 0, make, whew, okay, this is going to be interesting. I'll have to think this through. Huh, this is going to be interesting. Okay. So now I'm more making almost like a list, literal list type of thing with the self-referential things in here. Nothing. Replicate number of cells. Make cell metadata. Nothing. And then I'll have to basically get everything else. But I still won't have the index, so I should find a way to get the index here. God. What do I do here? Do I do anything here? Get cell from index. We take the maze, index, and get the cell. That's fine. But I need this number. Replicate number of cells, make fresh cell. It's great. But is there a way to keep this index? Yeah, that doesn't help. I wish finding shit would be better. Oh, index pairs each element with an index. So we could do that, where we could just make cell metadata and then paired with an index. Wait, what? Wait, we have a update at? We don't have to use lenses? Update at applies a function to the element of the index and then either replaces the element or deletes it if the function has returned nothing. If the index is negative exceeds the original, so will be returned. Wait. I don't have to use these confusing lens shit? Oh. Lens provide several type classes for index functions that work on maps, lists, vectors, bytestrings, and so on. But unfortunately, they're pretty slow for lists. Oh! Fuck! Why can't I just use modify at or update at? Jesus. This would be easier. Data.list.index. Modify at. Modify at applies a function to the element at the index. If the index is negative or exceeds the list length, applies a function to the element at the index, applies a function to the move index, and just replaces the element, deletes it. Oh my god. What? Oh my god. What is it? I list? Oh my god, I can just use... Hello, Jappy. Data lens has IMAP, though? Hello, Jappy Jappy. Functor with index. A functor with an additional index. Hey, Nightbot, you were correct. IMAP takes a function, takes an index A and B, a map with access to the index. Okay. I didn't know it had this. Oh, I'm gonna have to figure out how this works. But that's a good idea. I guess since I'm using lenses, I might as well keep using the lenses, huh? Alright, so this is the function we're gonna map onto, this is the function, and then this is that. Okay. Alright. I got this shit. Alright. Okay. We can do this. Lenses all the way down. Alright. No, I've just been basically spending this whole entire episode figuring out how exactly to make it so I don't strew IO all over the place, and I finally figured out a solution. But yeah, IMAP is what it is. IMAP. So it takes a function. So I'm gonna make a list of the cell metadatas, and in there I'm going to I need the function. Okay, from there, okay, so IMAP, and I'm gonna IMAP. So I need IMAP. Oh my god. So right, I first need the list of empty cells. So I have empty cells. Or even better, I have a list of so I have a list of cell metadata. So I have a list of cell metadata. Cool, wonderful. I have an empty list of cell metadata with just make fresh cell. That's it. Okay, cool, great, wonderful. I guess index should also be maybe something I can do it as 0. I think it's a good idea right now. It says this doesn't have an index. That would be a good idea, I think. So we're gonna have just that. We're gonna do this. We're gonna do a maybe index. We're gonna call this a nothing. Okay, cool, wonderful. So we have that. Now, this should not be called make fresh maze. This should be called make fresh maze, but I'm not going to do with that right now. Just replicate number of cells. Cool. Or, no, we need an original list for IMAP to work. Okay, so, yes, we make fresh cell, and then, I guess fill cell metadata? Fill cell metadata, and then from there, we need a function that takes an index and an A and a B. So this would take a function that would be an index I. So int, I'm just going to say int. So a function that takes a cell metadata, returns a cell metadata. Oh, but no, this isn't going to work. Because in order to get the neighbor cell and the neighbor index, I need to know what the direction is in the first place. And that isn't going to work. Then we're getting into the same issue that I had before. Because let's say I did go through with my change, and let's say I did have a cell metadata with the cell, the index, and the neighbor cell and the neighbor index. Once I knew the direction, which the maze, are you making a matrix of cells? Yeah, I'm just making a, yes, I am, except I'm putting it all in one list. Yes. The reason, yeah, just a straight array. In this case, a list of just cells, and then from there, I'm going to know what to do and know how to do more stuff with it. So what I'm going to need is the problem that I'm having right now is that a cell needs to know what neighbor it has, but then that neighbor needs to be able to go backwards as well. And so that's a bi-directional neighbor. So if you have a cell, here, and it has a neighbor up to the north, this cell also needs to know that it has a neighbor to the south. And the reason why I need to do that is because I'll eventually need to use a depth-first search to figure out how many cells are away from a starting cell. So in this case, I'll just do cell 0, 0. And because of that, I need to go back up. I guess I could use recursion. That would actually work as well. I could use recursion. Then I don't have to worry about bidirectional cells. And then I can just worry about the stack. Then the Haskell can... I don't know if I put the stack that way. That's an interesting idea. So the problem that I'm running into is... Well, I was able to do this with, I know C# and Haskell are totally different. I was able to do the C# with just being like, with the stack iteratively, or I used recursion, be like, here's the cell, go to the next one, go to the next one, go to the next one. But still, even before that, even though that might be complicated, the problem that I'm running into now is I'm going to pick cells at random. I'm going to go through all 25, or this, I'm just going to go through them iteratively from index 0 to 24. And I'm going to go, do you have a neighbor to the north or to the east? Now, I don't know if I showed you this before. I'm going to open up a visual representation so you can see what's going on and the problem that I'm encountering right now. Go to mazes, bin, debug, hello.png. So every square, basically the idea, the algorithm is that every square, I'm going to go to every square, I'm going to go, do you have a north neighbor or do you have a neighbor to the east? So as you can see, all the cells on the top row have a neighbor to the east. Because if you can't have an opening to the north, because if you do, well, then you're out of the maze. Likewise, every neighbor on the east wall has a neighbor to the north, because that's the only neighbor you can have. So those are fine. But then the hard question is, well, what happens when you get into all these cells in the middle? And so what you need to do is you need to basically flip a coin and go, okay, get a random number. If it's 0, make a neighbor to the north. If it's east, make a neighbor. If it's 1, make a neighbor to east. Simple. But because this deals with random numbers, it means getting a random number generates an IO. So what I had before last episode was I had apply direction, and I realized directions is actually an IO of a direction, which means that this is going to have an IO of a maze. It's going to return an IO of a maze, and the index and neighbor cell and neighbor index are also going to get neighbor cell from index, get neighbor index from cell are also going to be IO methods because it touches an IO of a direction, which means IO is going to go everywhere, and we don't want that. So what I found out last episode was I can just do this. I can say a cell has either north, south, east, west, or a random direction. And then when I'm going through, I can go, okay, if you're north or you're east, do this. Don't worry about random. And then once that's done, I can then go, here's all the cells. So I can take this tuple of cell and direction, and I can go return all tuples where the direction is random. And then I can change that random direction to an IO of a direction, so I can get IO of north or IO of east, and then apply the cell and IO of a direction tuple to the maze, and then I'll finally have an IO of a maze. But the problem with that is I'm still going to have to convert the point to index. Additionally, I'm still going to have to get the neighbor cell and neighbor index, so I can apply the bidirectional neighbor. And with that, again, we're going to spread IO to get neighbor cell from cell and get neighbor cell to index. So, what I was going to do was I was going to have, instead of cell and direction, I was going to have something more like this. So we have a cell, and then that cell, basically an object type, a record, with a cell, with an index, and the neighbor cell and neighbor index, calculate all of this ahead of time, and then that way, I'll deal with cell metadatas But the problem with that is the only way to get the neighbor cell and the neighbor index is to know what direction you're going. So I could make a list of cell metadatas passing in a tuple of cell and direction. And I could store these all. I think I might be doing that next episode. I'll try that. What? Is that a joke? Or is like entropy an actual type in Haskell that I don't know about? Because what I get from you can just generate a bag of entropy is like, it's so complicated, just freaking make entropy and you'll have be a better life doing that. But I don't know. But if I generate random... So the only way I know how to generate random numbers, now I might be wrong, again, like, I didn't even know about IMAP because I didn't even know to look for it, is if we go to get random direction, returns an IO of a direction, and that's because we have to call random RIO because we have to change the seed for the random number generator. So wouldn't that list just be an list of IO of numbers? And then anything that touches that list also has to be declared IO, right? But that is an idea to just generate the numbers first. And then... Hold on. That is an idea. That is another idea. Sir, you think well. That is another idea. So basically generate that list of random numbers and then pass that list along, and then I'll just be able to like grab this one, and then I can just basically just grab from the start and then just take it away. That is a good idea. I like that. It has been an hour though, so it is time for me to go. But I will take that. I think that's where we need to go. I think that's what I need to do. Thank you so much for your idea. That's great. But yeah, I will end it here, but next week I'll totally be following that logic. But so anyway, it was great. Thank you, Jabba Jabba, for the idea. Lurkers who are lurking, thank you so very much for lurking. Watchers who are watching, thank you so very much for watching. Bots who are botting, thank you so very much for botting. What we got done today was mostly nothing. We tried to figure out how to get around this IO. Not get around, but use it in a way we need to use it. I think we got pretty good so far, which is great. So, if you guys want to, I will be streaming tomorrow at 11 in the morning. I'll be doing more serverless stack. Guys, this one on YouTube. So if you're watching this on Twitter, if you're watching the VOD, give me follow, because I like those follows. If you're watching this on YouTube, give me a thumbs up if you like what you see. Give me a thumbs down if you hate what you see. But in any case, give me a comment and a subscription, because I like those. Additionally, guys, buy a shirt. It helps support me. It supports the stream. It makes it so maybe if I get enough money with shirts and coaching, I could do this more, which would be great. I also do offer coaching for $60 an hour. Email me at darren.hona@thatprogrammingguy.com. Oh, right, guys, I totally forgot. I have a Discord. I'll make sure to put that in the stuff below. So yeah, I love you all. Thank you so very much for watching. I'll see you tomorrow. Have a wonderful day. Bye-bye.